Welcome to Spare Part Stock Analysis Process Descriptions, and thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our service and training offerings. Spare part stocking analysis addresses spare part stocking strategies, like whether a part should be physically stocked, and if so, how many of it should be kept on hand. The analysis part of spare part management is enabled through consistent labeling, so we need some rules about what information is necessary to make up a complete part record. Finally, rotating spare parts are discussed and explained. Like all functions, there are 4 processes for spare part stock analysis. These are designed to be developed in the order shown, but implementation is generally done simultaneously. These processes answer the questions: what should be stocked, how much should be stocked, how the parts are identified, and how do we keep track of rotating spares. Here are the benefits of the spare part stock analysis function. Having rules for what to stock is intended to ensure spare part management is linked to a risk-based asset management program. One of the reasons to stock something is because it was identified as supporting a very high priority failure mode. This is still a bit of an art form, having rules for how much of an item to store. This puts some process around those decisions, though, and it provides a baseline for later adjustments as necessary. Data requirements support continuous improvement and overall accuracy of the spare part management system. When you're working with clean, complete, accurate data records, the reports and analysis indications from the data can be trusted, and the associated action plans become more effective. Having a method of keeping track of rotating spares' location and function removes another variable from spare part management by removing ambiguity about which rotating part is where at any point in time. Because of all the preparatory work performed in Reliability Management System to classify assets and failure modes, we're able to use data in a straightforward way to help us decide which things should be stocked and tracked in the CMMS and where they should be stored. A process is used to ensure the stocking decisions are all based on a process model. This slide shows the 4 outcomes for stocking decisions. Level 1, the spare part is not in the CMMS and it's not stored. In Level 2, the spare part is kept in the CMMS, but it's not stored. Level 3, the spare part is recorded in the CMMS, but it's stored by a part supplier. And Level 4, the spare part is recorded in the CMMS and it's stored in-house. These values are based on evaluation in the following categories: criticality, which is based on failure mode priority, and possibly other site-specific inputs important to a specific business model or product. Turnover. The more being used, the more important it is to make sure they're available. Lead time. The longer it takes to acquire or the more unpredictable the lead time, the more important it is to make sure there's availability. Cost. Not necessarily as important as the other categories, but having high-cost spares available buffers the impact of sudden need to spend money on acquisition. Think capital spares. The criteria are evaluated in each category, and a score calculation is then established for spare part prioritization. The higher the criticality, turnover, lead time, and cost, the more important it is to have the part in hand. The key here is to ensure spare part prioritization decisions are made using a consistent set of rules that make sense to the business. The next thing to do after deciding what to stock and where to keep it is to figure out how much of it will be needed to support asset management, which means no unexpected downtime related to spare part unavailability. There are literally hundreds of equations available to calculate stocking quantities, but they all make some assumptions that data is available. Typically, data is not available at the level of confidence that would make the calculation meaningful beyond a relative comparison tool. But don't be put off by this. There's another way to baseline without all that shown here. First, just figure out how much you're using, consumption, and then apply some safety stock values based on the assumption rates and lead times so you don't stock out, and then determine the reorder point based on the safety stock and the lead time. The point of all this is to have some process behind how much stock you're carrying, not to be spot on the first time you try to figure it out. Have you noticed how we visited consistent documentation for assets, failure modes, proactive tasks, and now for spare parts? Why do you think that's the case? Correct and complete data records are essential to effective asset management. In data world, one missing or incorrect value renders the entire data population at least somewhat suspect. Describing spare parts consistently benefits everyone who interfaces with the information. Here are some suggested data fields that can be helpful toward establishing rules that define the minimum required data related to spare parts. You see nouns such as bearing, modifiers such as maybe roller bearing, manufacturer such as SKF, manufacturer part number 1234, and attributes such as the size, type, material, or rating. There are other considerations to decide how to define a complete part record. You might consider chemical process data, physical process data such as temperature, pressure, supplier test requirements before delivery, material specifications and limitations such as asbestos-free or shelf life, the maintenance requirements while it's in storage, the storage conditions, and the installation instructions. Rotating spare parts require some rules to manage them correctly, but if you understand how we define asset, subassembly, and spare part, you shouldn't have any trouble with this. First of all, rotating spare parts could be just as correctly called rotating assets or rotating subassemblies. It really doesn't matter because rotating spare parts meet the defining criteria for all three classifications. Let's see why they are so special by examining the operational life cycle of a rotating spare part, using a process mixing tank agitator as an example. The agitator consists of a mixing blade, drive shaft, coupling, motor, and a tank mounting flange. You remember the criteria for an asset? Provides a primary function, provides process control, is regulated, or expensive to replace. The criteria for a subassembly? Provides a function to an asset, may be maintained separately from an asset. And spare part is an interchangeable component that fails in one or more ways. In other words, has distinct failure modes. So we can see that we are correct however we classify the agitator. The thing to remember is that we have to know where each agitator is located, whether installed, being maintained, or in storage waiting for its next installation. Most modern CMMS configurations treat rotating spares as special cases. The terminology is typically rotating asset, and by flagging something as a rotating asset, it is assigned a log of movements. Examples are moving from one location to another, with each move documented in the CMMS. Another might be assigning it to a user, such as an expensive specialized tool that needs to be checked in and checked out. A rotating spare can be assigned to a business unit, or even attached to a work order. The point is, whatever we call it, we have to know where it is in real time, all the time. First, we acquire the rotating spare part. In the case of the agitator, we either specify the agitator as part of a tank package installation, or we bought the agitator as a spare for existing agitators that are already installed and operational. In the first case, the agitator is a subassembly of the tank. In the second, it is more like a spare part, but if it costs a lot, it might be an asset. The key is in understanding the intended use of the agitator. Is it used in batch production? If so, the entire tank assembly might be disassembled, the various parts and subassemblies cleaned, then stored in various locations to later be assembled interchangeably with other parts to form a functional process mixing tank. In cases like this, identification is key because of equipment traceability requirements related to batch records. Each rotating spare part has a physical and virtual record, just like an asset. To summarize, spare part stock analysis requires determining what will be stocked and where it will be stored. Then we figure out how much of each stocked item we want to have on hand. Spare parts are documented consistently across the business to allow us to leverage spare parts management. And finally, we develop a way to keep track of our rotating spares. This concludes the spare part stock analysis process descriptions presentation. Thank you for participating.